The problem area that my group is focused on for our capstone project this quarter and the following quarter is looking specifically in the biotech and healthcare space, understanding cardiologists and radiologists' impact and interactions with disease and using neural networks to create predictions for better understanding the cases in disease interpretation. So predictions in using machine learning models really impact the understanding for doctors and radiologists in the domains like healthcare. But unfortunately, the problem that we have understood is that machine learning models really act as like black boxes that they produce predictions, but they don't provide a very clear, human understandable explanation to what made those predictions. In our focus, we are looking at a disease called pulmonary edema, which is fluid in the lungs. Obviously, it is not a good disease. It's very indicative of heart failure and other problems later in life. We're collaborating with radiologists and leveraging neural network models to really understand how we can use that model to better understand the biomarkers for those predictions and create some explainability from it. This idea is honestly very interesting to all people and just an audience in general because many people are impacted by having high, accurate, and predictive models, whether it's in industries such as healthcare, finance, or policy. Models need to predict something just and impactful, and it should be very interpretable to the audience that we're working with. And something that we identified is that there lacks that interpretability in terms of clinical cases and working with doctors and radiologists. So that's a specific problem that we're looking at is current explainability falls too short in the way that it's measured right now. Existing tools such as Shapley additive explanations, also known as SHAP, are very technical, which make it hard for non-experts to interpret those values, such as clinical radiologists or scientists or doctors. And these values don't really explain when a model is run. These values don't actually explain what made those mistakes. They're not very robust and provide that insight deeper into the predictive outputs. So there's that gap between the like actual language evaluation of a model and the results that it provides. So our approach to this problem would be to leverage large language models to make machine learning models, such as like the neural network we are working on, understandable to humans. So leveraging machine learning neural networks with large language models allow for more explainability and a human readable explanation to the type of results that we are working with. Some of the main questions that we wanted to focus on are how can LLMs translate technical outputs into more domain specific English outputs? How can we summarize patterns of feature importance? And how do LLMs perform a deep error analysis? So some of the success metrics that we are going to use to evaluate if this using the LLM along with the machine learning model actually improves model interpretability. We want to evaluate the clarity and usefulness based on specific accuracy scores, leveraging machine learning model validation metrics such as Pearson R, and then also just collaborating more with the actual stakeholders we're working with to ensure that natural language explanations by this process actually make sense.